Good morning students. Today we are going to discuss about the Fermat's little theorem. So this is used for the finding out the exponentials in the primes. So this Fermat little theorem will state that whenever p is a prime number and a is any positive integer which is less than p, then you can write the formula as a power p minus 1 is congruent to 1 mod p. So from the Euler's theorem, you know that the theorem says that a power phi of n is congruent to 1 mod p, where phi of n, when the n is the relatively prime, then you can write as n minus 1. So similarly here also you can write as a of phi of p is nothing but p minus 1 is congruent to 1 mod p, and you have a second version where you can write as a power p is equal to a mod p. So let us see the example related to the Fermat's little theorem. So in this, here we have given that 6 power 10 mod 11. So when you are writing 6 power 10 mod 11, you can observe that whenever you find the A and P values, the GCD value should be always equal to 1. So the GCD value of 6 and 11. So what is the GCD value of 6 and 11? It is equal to 1. So obviously these are relatively primes, and you need to find out the exponential. So this exponential value is less than the value of the prime. So whenever it is less than value and it is in the form of a power p minus 1, which is congruent to 1 mod p. So here p value is 11 and a power p minus 1, that is 6 power p minus 1, that is 11 minus 1 value is there. So obviously the value will be equal to 1. So this first version of Fermat little theorem where p is equal to 11. Then coming to the next another example, here it is given as 3 power 12 mod 11. So when you are taking 3 power 12 mod 11, it is in the form of a power 12. So first we need to find whether the GCD values of 3 comma 11 is equal to 1. So when the GCD values of 3 comma 11 is equal to 1, then they are relatively primes. So yes, they are equal to 1. Then you can find out that the exponential value is greater than the 11. So this particular exponential value can be written as 3 power 11 into 3 mod 11. So how you can write? You can write this as 3 power 11 mod 11 into 3 into mod 11. Now this 3 power 11 mod 11, it is in the form of the formula a power p is congruent to a mod p. A mod p. Then obviously what is the remainder value? That is a. So here you are going to get the value as 3. And what is the 3 mod 11 value? 3. So 3 3 is a 9 will be your answer. So you can find the solution. So similarly you can find the value is equal to 9. Then coming to the multiplicative inverses, so you can represent the formula as A inverse mod P is equal to A power P minus 2 mod P. So when you are taking an example, here we can, without using an extended Euclidean algorithm, you can directly find out the multiplicative inverses. So 8 inverse mod 17 is nothing but 8 power 17 minus 2 So 17 minus 2. So this can be represented as a power p minus 2. So 17 minus 2 mod 17. So 8 power 15 mod 17, which gives the 15 mod 17. 15 mod 17. And similarly you can get the values, which is nothing but 14 mod 23 for the values over here. So similarly you are going to find all the values without using the extended Euclidean algorithm. Then coming to the multiplicative inverses for the composite values without using the extended Euclidean algorithm, you can find using the phi of n minus 1. So phi of n minus 1. When you are finding the phi of n value, that means this is the Euler-Tauschent value. So the finding out the Euler-Tauschent values, how we are going to find out? So here 8 inverse mod 77 can be written as 8 phi of 77 minus 1 mod 77. Now this 77 can be written as 11 into 7. Now 11 into 7, you can write this value as 8 power phi of 11 into phi of 7. Now phi of 11 you can write as this is a prime number. You are going to write the n minus 1 value, that is 11 minus 1, which leads to 10, and here also it is the prime number. So 7 minus 1 leads to 6. So 10 into 6, that is 60. 60 minus 1 gives the results as 59. Then when you are finding out 8 power 59 mod 77, you are going to get as 29 mod 77. Like that you are going to find out all the values similar manner. Then coming to our next topic, that is primality test. So this primality test is nothing but to find out in the algorithm, that is correctly and efficiently test for a very large, that is whether the prime number has been coming at the composite, that is always challenges the number theorem. So this primality test will test whether the whatever the prime number that is coming is really a prime number or it may be a composite number. So it checks the primeness. So we are going to have different sessions, that is deterministic algorithm, probabilistic algorithm, and the test. So in this deterministic algorithm, we have an algorithm, that is divisibility algorithm. So when you are taking the divisibility test, so when you are taking any number using for the primality, so then we are going to apply the r value is assigned to 2, then r is less than the root n. So always you need to check the n, the root of n, as you know the primeness of root n. So when you are taking the root n values, you are going to get the values of the suppose any integer, then you are going to take all the primes that are there of the n, and when you are dividing by the 2, when we are dividing by 2, if it is a composite value, then you test not the prime. When it is equal, when it is not equal to the value, then when it is divisible, then we can say as a composite value, or we can say it as a prime number. So bit operation complexity is a divisibility test is a exponential. Then probabilistic algorithm. So in the probabilistic algorithm, the fermat test will be applied. So in the fermat's theorem, so whatever we have applied, that we are going to test. So here we are going to test the n is whether the prime number or not. So according to the Fermat's little theorem, a power n minus 1 is equal to 1 mod n is a formula. So we are going to test whether the n is a prime number or it may be a composite number. So for example, if you give the example as 561, according to the Fermat's little theorem, we are going to pass on the Fermat's test, but it is not a prime number. So because we have the factors, that is 33 into 17, where 33 has the factors. So this is not a prime number. And does the 561 passes the Fermat test? Yes. So according to the Fermat test, that is 256 minus 1 is equal to 1 mod. Like according to the theorem, that is a power p minus 1 is always congruent to 1 mod p. So here the p value is here as 561 and a value is equal to 2. So these both are relatively prime. So because the GCD values of 561 comma 2 is equal to 1, and when you are taking this formula, according to this formula, what is the value here? That is 1. So this 561 is passing the Fermat test, but according to the test, we are not having the, but it is not the prime, because the 561 is not a prime number because it has the factors. Then coming to our next one, once you have checked for the Fermat test, the other testing method is the square root test. So here we have the certain rules that we are going to follow. The first rule is to have the prime number. So we are going to find out the mod n values, root of 1 mod n, which should be always equal to plus or minus 1. If you are getting plus or minus 1, then we can say it is the prime numbers. And this 1 values should be limited to only 2. If it is more than, that is plus or minus 1 is more than the 2 values, then we are going to say it as the composite value. So how we are going to check this particular value? We are going to take as x square mod n. So when we are going to check using the x square mod n equation. So when you are taking an example over here, so what are the square roots of 1 mod n if n is the 7 as a prime numbers? So according to the rule, we are going to take all the values that are existing. So what are the values that we are going to take? So we are going to take 1, 2, 3 so on till the 6 values. So n minus 1 values you need to take, and you need to check using this x square mod n. For example, I can say for 7 the values are 1, 2, 3, 4, 5 and 6. Now when you are taking 1 square mod 7, 2 square mod 7, 3 square mod 7, 4 square mod 7 and 5 square mod 7. Like that you need to find out till the n minus 1, and 6 square mod 7. Now 1 square mod 7 which leads to 1, 2 square is 4, you are going to get 4, 3 square mod 7 that is 9, you are going to get as 2, then 4 square is 16, 7, so what is the value you are going to get? 14, so 2 is the answer. So like that you are going to find. So here, since you are having the values as 1 and minus 1, so it is satisfying only the 2 1 values. So we are going to say 7 is the prime number. 7 is the prime number. So if it is more than the two values, if you get one value of more than two, then it can be said as a composite value. For example, you can take 8 as a composite value. So you can say that is once you find out the square values, that is 1, 3, 5, 7, you are going to get as one value when you are applying the mod 8. So you can say since we are getting more than more than the two ones, we can say this is a composite values. The only condition is you should get the values only related to only two ones. Whenever you finding the plus or minus 1 squares, so you should get the values as only 2. If it is more than 2, then you can say that number as a composite number. Now here also, what is the square roots of 1 and n? So n is a finding out the 17 as the prime number. Here also since 17, so we need to take all the values and find out the squares. So here also we are getting the only two solutions as the 1. So 17 will be the prime number. But in another example that we have seen, if at all you need to find the 6 is the prime or not, so what we need to find, if at all the 6 is prime number or not, so we are going to find the 1 square mod 6, 2 square mod 6, 3 square mod 6, 4 square mod 6, 5 square mod 6. Now according to the values, you are going to get only the 1 square, that is 1 square is equal to 1, 2 square that is 4, you are going to get 4 only, 9 you are going to get 3, 16, so here you are going to get 4 and 25. So when you are writing over here, you are going to get that is plus or minus 1 value. So here if you take the minus 1 values also, you are going to get the 1 mod 16, 1 mod 6. So here the only two values are getting, so 6 should be the prime numbers. But as you know that 6 is not a prime number, but 6 is a composite number because you have the factors for the 6. So using the square roots, you may not get all the values as exactly the prime numbers or not. So for that reason, this particular also failed to find out whether the prime of the values are existing or not. To find out that, we have gone to another method called as Miller's-Rabin test. So this Miller's-Rabin test is always 99.9% is having an accuracy in finding out whether the number is prime number or not. So it uses an equation like n minus 1 is equal to m into 2 power k. So the idea behind is we are going to find out the values k times, that is 2 power k time we are going to apply. So we are going to apply the test for k number of times. So the Miller's-Rabin test need to from the step 0 to step of k minus 1. So here we are going to find out the test. So we are going to take n as the number and a is the base value. And we need to find out the values, that is n minus 1 value should be equal to m into 2 power k. So we need to find out here, that is we have assigned the t value as a power m mod n. Now why this t value is find out? When you are getting the t value, if at all it is plus or minus 1, then you can say that value as the prime number. Now, if it is not equal to, that is, if it is greater than the 1 value, then we can say, or we can go to the finding out the t value, that is t square mod n. Now this t value, if it is plus 1, then it is a composite value, and if it is minus 1, then it is the prime number. So like this we are need to find out. So whenever the values is less than or equal to 1, we are going to use the equation as t is equal to a power m mod n, and t is equal to plus or minus 1, and returns whether the prime number or not. If it is t is greater than 1 value, then we need to check for the values for t square mod n, and whether it is plus 1, then it becomes a composite value. If it is minus 1, it returns the as the prime number. So let us take the 561. So in the previous example, you have noticed that the 561 is not the prime number, but it is a composite value. So let us see whether the Miller's-Rabin test is working out and showing it as the composite number or not. So according to the theorem, we are going to write as a. So what we have written as, that is m into 2 power k. So you can write as 35 into 2 power k, where k is equal to the 4 value. So m value is 35 and k value is equal to 4. And what is the a value here? 2. So we are going to test the value as t. So t value, how we are going to test? So according to the formula given here, t is equal to a power k mod n. So here you can observe a power m mod n. So you are using the values a power m mod n. So you are going to get as 263 mod 51. So here t value is equal to a power m mod n, you need to find out. So once you have find out, if the value is t or is equal to the plus or minus 1, then we can say it is a prime number, or else we need to find out the t square mod n, and we can observe that whenever t is equal to plus 1, then it becomes the composite value. T is equal to minus 1, it is become the prime value. Now we are going to write 263 mod 561. Then we are going to, since the t value is equal to, find out the 263. So then we are again decreasing the values. So we have got the values as plus 1. That means so we are applying here t square mod n. So according to the formula here, we can apply the t is nothing but t square mod n value. So t square mod n values we are going to apply till we get the reduced values of either plus or minus 1. So we have got the plus 1 value, which is nothing but the composite value. So Miller's-Rabin test works perfectly. So like I said, it works as 99.9%. It gives the accurate value. So you can also find whether the 27 is the prime number or not using the Miller's-Rabin test. So with the base 2, so whenever there is no base given as in the exam, in the problem, you can take base value as 2. So we are going to write as 13 power 2, 13 into 2, that gives the 26. So we are going to write n minus 1 is equal to m into 2 power k. So m minus 1, what is the value? 27. 27 minus 1 is equal to 13 into 2 power 1. So here m is 13, k is equal to 1 and a is equal to 2. And we are going to find out the t value. T value is nothing but a power m mod n. So when you are finding the values, we should get the values. So we have got the value as 11. So furtherly we are going to find out the value using the t square mod 27. So when you are getting the positive values, so what we are going to apply? T square mod n. So then it returns as a composite value. So like this we are going to test the Miller-Rabin test. So this is regarding the primality test concepts. Thank you.